All right, part 2 of our lesson on graphing radicals. Sometimes you will see radicals where it's not just a regular x. There's a number on the front of the x on the inside, like here or like here. If you see that, all bets are off and you cannot just count out left, right, up, down. So you have a few options here. You could make a table, you could throw it in the calculator, or there's actually a way you can still graph this by hand. What I'm going to do with this is factor out a 9 from these and do like a little GCF. If you do that, it's going to go 9, and then that would be an x minus 3. So this is cool, but this is not done either, not helpful either, because I still have a number on the inside with x. But I am allowed to split this up into two separate square roots. We've learned that already with our square root operations, radical operations. Then if I do it like this right here, the square root of 9, is just plain old 3. So this looks like something from the previous videos that I can totally count out. So I would go right 3. It's a positive and a positive, so that's up and right. From right here, that's my first step, I would go up 3, right 1. I would hit my dots, and I draw my picture. So if you see a number in front of x, you can do a GCF, pull out that GCF and do a square root, and then graph it like normal. That actually even works when your numbers are not so nice like on this next one here. So I see a 2, and 2 doesn't even go into 3, but I'm going to pull out a 2 anyway, just so I can actually use this rule. If you divide both of these by 2, you're going to have x plus 1.5. Then I'm going to do separate square roots like I did over here. The square root of 2, though, not so nice. The square root of 2 is like 1.41. So this is going to turn into kind of a mess here. So this is one maybe you just want to use a calculator, and that's fine. But I did the square root of 2, and then I'm going to have x plus 1.5. So what I would do is I would go left 1.5. Don't go up or down at all. And from that in-between spot, I have to go up 1.41 over 1. So when I go over 1, I'm just like in between these tick marks, and you get a graph like this. So long story short, on problems like this, if you divide out a GCF and do the square root on it, you can still use the counting rules. We're going to finish off this section by learning how to graph cube roots. Okay, and we'll do this pretty quickly. Cube roots, we're going to start with a table because we know they should make a new shape, and actually we already have the shape from our last video here. But thinking about numbers with nice cube roots, cube root of 0 is 0. Cube root of 1 is 1. Cube root of negative 1 is negative 1. So those are all going to be nice points for me. I have negative 1, comma negative 1. I have positive 1, comma positive 1. If I wanted to get 2 more nice points, the next nice cube root after 1 is actually 8. The cube root of 8 is a 2. And the cube root of negative 8 is a negative 2. 2, 3, 4, 5, 6, 7, 8, comma 2. And then I got to go to negative 4, 5, 6, 7, 8. So cube root graphs actually do go both directions. They don't have that empty dead space like square root graphs could do, because you're allowed to plug in all numbers. With square roots, you can't have a negative on the inside. So I get a picture that looks like this, and we actually graphed this one already in the last lesson. You can see that it's consistent with what we had there. So, domain and range for cube root graphs, not terribly exciting. The domain, it goes left and it goes right, so it's all real numbers. It's going to hit all x's. There's nothing you can't plug in because this is an odd index. The range, this graph grows super slowly. My next nice point after the 8 is going to be 27, comma 3. and then it's 64, comma 4, 125, comma 5, but it does really slowly keep on rising, so you will eventually get every output as well. So it's all real numbers for both on these. When you draw your cube root graphs, make sure they're very, very flat or very, very not steep. Not entirely horizontal, but not very steep at all. So when we graph one of these guys, I'm going to make you just do these 3 middle points right here. And we can still count this out just like all the other ones. Notice right here, we start at 0. We would go up 1 over 1, and we would reverse it, down 1, left 1. So this picture is moving left 1, and it's moving down 3. That would place me here. There is a -2 out front. I'm going to go down 2, and then that's over 1 right here. But this dot, and I should make it a little bigger, is my center dot. I will also, from my center dot, reverse that, go up 2, left 1, and get another dot like there. So then what I do is I go really, really not steep. I hit my 3 dots, and I go really, really not steep this way as well. Very flat sides here. Cube root graphs have kind of this S, swoop, snake, I don't know what you want to call it, looking shape to them. And the domain and range are all real numbers for both.